these problems we're doing the exact same method as the last ones. It's just that these are more involved because there will be more factoring involved. So I don't know if you can see my notes, but I want you to have an idea of how much room to leave on a piece of paper. So this is two problems. I used all of the left side for one and all of the right side for the other. So if you're trying to figure out how to plan your notes right now, get yourself some fresh paper. Those of you who are in class, if you would like to see, I use the whole sheet because they're kind of long. So this one right here, we have 4 terms, and the main difference on this one is that these two things don't have denominators in the same way that the other problems did. They do have denominators, they're over 1, we just don't write it. So to get started, in fact, I'm not going to do the step 1, step 2, step 3. We're just going to work. So to begin, make a note somewhere that you can't factor the denominators. So we didn't have to do that. So the first one is over 1, which you can't factor. You can't factor x minus 3. When you see the subtraction or addition, you have to group it. And you can look for a GCF, but there's not one. So can't factor that. And then on the right-hand side, that's over 1. And the x minus 3, we're going to group together. And it's the same as the other x minus 3, which we already said can't be factored. So we're going to skip straight to the next step where we start multiplying by the denominators. So I'm going to give myself a bunch of room here between the terms. If you'd like to do that on your notes as well, because we're going to multiply them by stuff. So starting with the first fraction, the x over 1, I mean, I could say, how do we get rid of a denominator of 1? And then you could say, multiply everything by 1, but we don't, that's trivial. It doesn't make any difference. So we're not going to go through the trouble of multiplying everything by 1, right? It doesn't change anything. So we're going to skip to the next fraction, the 12 over x minus 3. And to get rid of that denominator, which is our goal, we multiply by x minus 3. Okay, so the addition or subtraction means you have to group it. And so to cancel it, you have to keep the entire group. And so that would cancel here, x minus 3. But you can't just multiply that one thing by x minus 3. You have to multiply all the things by that. So a round of x minus 3. And I want you to look and find the other place in the equation where x minus 3 cancels. Yes, right here on the right-hand side. And so we don't even have to worry about canceling that one out now. It already did, right? So all my other denominators are just 1. So I can actually move on to the next step here. So let's bring down all the stuff we still have now. We have x times x minus 3 from the first fraction. We just have 12 from the second one. And then 1 times x minus 3 on the right-hand side. You don't have to write the 1. And then just 4x. And here we distribute this x through. X squared minus 3x plus 12. And then on the right, we can combine x and 4x. So now this is why the problem is going to take a little bit longer than the previous ones, because if you notice now, I have an x squared here. which is a quadratic. So we're going to have to be doing an extra layer of factoring that we didn't in the first section for today. So because you see that x squared, you're going to get this set equal to 0 by taking the 5x minus 3 and moving it over. Mm-hmm. Oh, because it's all addition or subtraction. There's no multiplication going on right there. Okay. So subtract 5x, add 3, both sides. That gives me x squared minus 8x plus 15 equals 0. And now we factor that. So I like the swing method, but it starts the same as grouping. What multiplies to 15 and adds to negative 8? Negative 5 and negative 3. And technically, at this step of swing method, you divide by the a value. But the a value is 1, and that doesn't change anything. So I use I put an x on the negative 5 and the negative 3 to make them factors. And then we set those factors equal to 0 and solve them. And then we resist the urge to congratulate ourselves and feel like we're done with the problem, because we're not done. We have to check that those solutions don't make any of the denominators equal to 0. So the denominators were, well, there was just one in this one. There was just the x minus 3, right? These are both the same. So we really just need to check that one. So here's my denominator that I'm checking. When I plug 5 in there, does that give me 0? No, so 5 is good. When I plug 3 in there, does that give me 0? Yes. Okay, so 3 is actually not a solution. So our final answer is going to be x equals 5. And then your directions on your homework will say identify extraneous solutions. So we'll say x equals 3 is extraneous. It's extra. It doesn't work, okay? So it's an extreme. It's extra wrong. It's extraneous. I guess neous means wrong. That doesn't mean that. It doesn't mean anything. So this next problem we're going to do is like the super level of all the problems for today. But before we go to it, raise your hand. Does anybody need this screen up anymore? Okay, everyone in class is good? All right, checked all my people. All right, so take a moment and write this down before I start talking about it. We're going to release the Kraken on this problem. So the first step is to factor the denominators. Every single one of these denominators has addition and subtraction in it. And I told you before, I said, if it has addition or subtraction, you have to think of it as a group. And that's still true, but now we have to notice one of them actually can be factored further. So if it can't be factored further, you just group it straight out. And the two denominators that can't be factored are this one and this one. And here's how you know they can't be factored. It's not a quadratic, so there's no factoring method, besides checking for a GCF. So you always do need to check for that. And those two don't have, those terms in each of those groups don't have anything in common. But the reason why this denominator isn't just grouped and then we stop thinking about it is because it's a quadratic. And so we have to try one of our factoring methods. So this is how I'm going to start the problem, is just by factoring that denominator. So we're going to factor that. So I start with my cross thingy. What multiplies to AC and adds to B? So AC is 6 times -1. So that's -6. And B is -1. So think in your mind which two numbers multiply to -6, add to -1. I hope you came up with -3 and 2. And for the swing method, this is the step where you divide by the A value. So here's my A value. So I'm going to divide by the 6. And this one simplifies to 1/3. And this one simplifies to -1/2. And we add x's onto those to make them factors, or n's rather, because we have n's. And this is where the swing part of the swing method comes in. For full-on factoring, so I'm not solving this right now, I'm just factoring it. I need actual factored form. You take this denominator here. So put your eyes on the screen for a second, okay? And don't write anything because I don't want you to miss it. So this is the swing part of the swing method. You take this denominator in this fraction and you swing it to the front of that variable. You take the denominator here and swing it to the front of that. And here's what that will look like when I rewrite. 2n minus 1 times 3n plus 1. And here's why that's helpful for us. Do you notice that those match these over here? So that'll come in very handy when we start canceling stuff here. So the only work I've done so far is to factor the first denominator. Now we're going to do the work where we multiply everything by what we need to cancel out the individual denominators. So this was kind of like just pre-work. So now I'm going to get to the problem. So I'm going to rewrite it with room between each thing. But this time when I write the first fraction, I'm going to keep it in factored form on the bottom. 2n minus 1 times 3n plus 1. I'm going to give myself some space and then write the next term plus 3n over 2n minus 1. Give myself some space and then write 4n over 3n. So looking at that first fraction, I need to multiply by all the things I would need to cancel the denominator. So I would need a 2n minus 1. And I would also need a 3n plus 1 because there's two groups on the bottom. So the 2n minus 1s cancel, and the 3n plus 1s cancel. But it's an equation. So everything I multiply that term by, I have to multiply everything else by to keep it all in balance. So 2n minus 1 times 3n plus 1, and 2n minus 1 times 3n plus 1. And now look at each of those terms and figure out what's canceling there. On the second term, the 2n minus 1s cancel. And on the right-hand side, the 3n plus 1s cancel. So when your steps say to multiply by the LCD, that's the blue stuff, the 2n minus 1 times the 3n minus 1 that everything got multiplied by. That's the least common denominator. And so here's what's left over when you take off everything that was canceled. On this first fraction, I have a negative 18 left. On the second term, I have plus 3n times 3n plus 1. And on the right side, I have 4n times 2n minus 1. So I want you to finish this problem on your own. And again, I'm going to quietly work it out here without talking so that my words don't interrupt your thoughts. But whenever you're ready to check your work, my work will be up here for you, okay? So you finish. I'm going to finish. I'll be quiet about it. Oh my goodness. You're like super. Okay, so I'm sorry if you're not done and I'm talking, but we only have a couple minutes. So here's my work. So the The black work on the left is all the algebra. So if you did not get -9 or 2, check your work with mine to see if you can find your mistake. The blue side is where I'm talking about checking the denominators. So we had 2 denominator factors. We had 2n minus 1 and 3n plus 1. So if you plug each of those numbers into each of those, remember you're just checking does it make it 0, and it doesn't in any of the cases. So your final answer is n equals -9 and 2.